Hello everyone, my name is Önder, and today I will be talking about foreign keys on Citus and some of its details on Citus. And yes, let's start with. So as I said, my name is Onder Kalaci, and I have been working on Citus and Postgres around 9 years now. So I put Postgres in parentheses because my main focus area is on open source Citus extension, but still when you work on uh, for a large extension like Citus, you also spend quite a bit of time with Postgres. So that's why I also count myself as a Postgres expert as well. And then during these 9 years, I had the opportunity to work on various parts of Citus, including the areas that I will today be also talking about, the foreign keys in Citus. And then I'm currently a principal software engineer at Microsoft and working on anything related at Microsoft and Azure. So first of all, I want to clarify why I picked this topic, because I frequently get questions about foreign key support in Citus. So I can understand the questions because there are really certain trade-offs and limitations of using foreign keys in a distributed environment compared to vanilla Postgres, like a single store database. So that's why in this talk, I want to clarify some of the concepts regarding Citus and then try to get the viewers also a similar mindset of mine about the foreign keys in Citus. So let's first define foreign keys and remind foreign keys to everyone again. So the fancy word for foreign keys in the database terminology is referential integrity. So it's actually an essential tool for designing a well-structured relational database. So it's actually also one of the critical parts of a relational database because it is one of the points where some relations between the tables in a database are created. So the foreign keys are really essential to the relational databases. And then the basic idea behind foreign keys is that it basically checks that any value inserted into the foreign key already exists in the reference table. So this is something you would want in your application, and then like it's much easier to delegate this job to your database instead of trying to enforce these kind of relationships within your application. So, for example, now I'm showing a SQL statements for creating two tables and then creating a foreign key between these two tables. In this example, assume that you have a customers table and orders table. So you can have multiple customers, and then each customer can have multiple orders. But then each order has to be owned by a customer. So if you have these kind of relationships between your tables, between your data, you can create a foreign key. You can use foreign key constraints so that the database enforces it for you. So if you create such a foreign key, then you can always be sure that all of your orders belong to a valid customer, for example. So you can ensure this within the database. Okay. So what happens when you create a foreign key in Citus and Postgres? So basically, under the hood, Postgres and Citus creates a trigger per foreign key. And then the trigger is associated with the foreign key constraint, and it's used to enforce the constraints. And the trigger typically checks whether the data being modified or deleted consistent with the foreign key relationship and takes the appropriate actions. And then under the hood, what's actually happening is running a SQL command. So in this slide, I also show actually screenshot from PostgreSQL source code. So this is basically what happens when a trigger, when a trigger that is associated with a foreign key is executed. What it's actually doing is running a select query on the reference table with the attributes of the foreign key, like with the columns on the foreign key, and then just checking if there are any tuples on that with these filters. And then it's also doing one additional thing. It's also adding for key share of X. So it's basically also acquiring some locks. So this is to ensure that within a transaction, if you see that the row for the reference tuple or the reference row exists on the reference table, then during your transaction you will ensure that no one can delete that or update that tuple before your transaction ends. And then let me also very briefly talk about the actions that can be taken by foreign keys. So up until now, I was actually talking about no action and restrict options. So it's basically producing an error indicating that the deletion or update would create a foreign key constraint violation. So if you just want your database to throw errors when the foreign key constraint is not holding anymore for your data, it's just no action or restrict. So there's a tiny difference between no action and restrict, but I will skip in that level of detail in this talk. But then you could also expect the database to behave differently. For example, you could say that, okay, if a customer is deleted from my database, I want all of its orders also to be deleted from the database. In that case, what you would use is to cascade option. So you could create your foreign key with a cascade option, so that whenever one row is deleted, like it cascades to other table, or similarly, if it's updated, the values in the other table is also updated. And there's also one more option, which is set null and set default. So for example, you can say that, okay, if a customer just, for example, is not valid anymore, if you delete that, instead of removing all the orders, you can set that the customer ID field on the orders tables should be set to null or default. So in general, PostgreSQL gives you some flexibility on what you want to do if foreign key is not holding true anymore with the data. Okay, now I'm switching to talk a little bit about the challenges of foreign keys on a distributed environment, like distributed database Citus. So the main difference is that the data is distributed across multiple nodes, multiple machines. And in that case, a foreign key relationship may span multiple nodes. And then communication between nodes can be slower due to network latency. And whenever the network is in the picture, there's always risk of possibility of network failures. And on top of that, so foreign keys are tightly related to transactions, and then distributed transactions can be more complex and more expensive to coordinate than in a centralized database like single node Postgres. So in general, like all the challenges of foreign keys in a distributed environment is about data collocation. So if the data is collocated within a single node, then it's almost trivial to just delegate the work to Postgres and then let it handle for us. And then how Citus approaches these problems. So as I said earlier, Citus delegates all foreign key related enforcement to local Postgres nodes. So Citus's role in supporting foreign keys is to ensure that each foreign key constraint can be enforced within a single node. And then basically Citus creates local foreign keys within a same node. So this, as far as our experiment, this is the only way to implement a scalable and robust foreign key support in a distributed system. And as of Citus 11.3, this is how we implement foreign keys in Citus. So of course, in the future, we might change this, but we also don't plan changes right now on this support. Okay, let's now talk a little bit more about Citus-specific concepts just to remind you so that we can talk about different trades of foreign keys in Citus. So Citus actually supports 3 different table types. The first one is local tables. And then the local tables are just regular Postgres tables where the data is available on the coordinator. So there's really not much involvement on the workers. And then reference tables are replicated across all nodes. So the exact same copy of the data of a reference table is replicated on all nodes in the cluster. And then the most common table type is on Citus is distributed tables, which are actually sharded based on a distribution column. So only the same shard ranges reside on the same nodes for different distributed tables. And then this is just a visual representation of the previous slide. So for example, we have the campaigns table, which is just a campaigns and companies, which are just local tables. They have their corresponding shards on the coordinator. And then ads is a reference table where we also have 1 placement of ads on the coordinator, and then we have 2 placements of ads on 2 different worker nodes. All of them are exactly the same. And then the clicks table is a distributed table which has multiple shards, like completely different data residing on different worker nodes. So this is just a visual representation of table types on Citus. Okay, so now let's get into the foreign key. So because like we have these different types of tables, now let's discuss the trade-offs and the limitations or anything between foreign keys between these table types. So when we talk about foreign keys between local tables, there are really no limitations because all the data for all local tables reside on the coordinator. We can very easily create foreign keys between the shards of the local tables and then let anything handled by Postgres. So there's really no restrictions. We can support restrict, no action, on update, on delete, cascade, and set null operations in this case. Okay, now the title has changed, but the information has not changed. Because when we talk about foreign keys between reference tables, there's really no difference to compare to the local tables. So this time, again, the data is replicated. So for any reference table, the data is replicated to all nodes. So this means that we can just simply delegate the foreign keys to the where this data reside. Like on each node, we will have now we will have one reference, one foreign key created between placements of the reference tables, and then we can just delegate everything, the rest, to Postgres. And then again, the title has changed, but the information has not changed. So foreign keys from local tables to reference tables. Again, there's really no restrictions. So the reference tables also have a placement on the coordinator. So this means that like anything, for example, a delete on reference table could also cascade to a local table because the data is already available and co-located on the coordinator for that foreign key relationship. So again, like in this case, there are really no restrictions and everything is just supported. Now let's get into a little bit more tricky parts of foreign key support in Citus. So when you have foreign keys from a reference table to a local table, then there are some rules that we need to consider. So foreign keys should not cascade or set null or default, because now on the coordinator, the local table could cascade to the placement of a reference table. But because the reference table has also placements on the worker nodes, those cannot cascade. So that's why we cannot support cascade operations in this type of relationship. But then for just restrict and no action types of foreign keys can also be supported because that can already be enforced on the coordinator. So there's no need, we can just we can just enforce it in a single node, and then it's already enough to cover the foreign key constraint between these tables. Okay, now let's get into foreign keys between distributed tables. So the first rule is that foreign keys can only be created among distributed tables within the same collocation group, because Citus only guarantees the data of collocated tables to reside on a single node. If two tables are not collocated, then Citus gives no guarantees about the data distribution of these two tables. And then very similar and related to the previous one is that foreign keys should always include the foreign key if you are creating a foreign key between two distributed tables. And this is necessary because the same shard ranges for the collocated distributed tables will reside on a single data node. And as long as the data is on the same node, Citus can create foreign keys between these two shards. So for example, if you have 32 shards if you have this collocation group of 32 shards, and then if you have two distributed tables, then creating a foreign key will result in creating 32 foreign keys between these 32 shards. And then there's also one more rule to keep in mind. So if you have a foreign key between distributed tables, foreign keys should not cascade, set null, or default. And this is actually coming from another limitation of Citus. So Citus currently does not support null values as a distribution column. So it means that if for example a delete cascades as null to another distributed table, then it would mean that the shard key will become null. But because Citus currently does not support null distribution key values in distributed tables, we also prevent creating foreign keys that cascades to null or also set default. Okay, let's also discuss maybe one of the most important use case for foreign keys. So users typically wants to create foreign keys from a distributed table to a reference table. So this makes a lot of sense while doing data modeling. So here again we start with the set null or set cannot cascade to set null or set default rule, because then it would mean that it could cascade to it could cascade for. Okay, I think I forgot something important to tell. So if you have a foreign key from a distributed table to reference table, you really don't need to include the distribution key of the distributed table. Any column in the distributed table can be on a foreign key relationship with reference tables. But then any column also includes distribution keys. So that's why we have a generic check that for creating foreign keys from distributed to reference tables, we do not allow set null. And this is similar to the previous slide, where if we allow set null to cascade, then it would mean the distribution column value of a distributed table could become null, and that is currently not supported in Citus. So that's why we don't support creating foreign keys with set null on this case. Okay, I think the most interesting rule to keep in mind with foreign keys from distributed tables to reference tables is this slide. So maybe to start with, so there's a concept in Citus which we call as sequential execution. So when you run for example, update command or a select query that spans multiple shards on a distributed table, what Citus typically do is fan out multiple connections and run and execute commands on the shards in parallel. So that's actually one of the superpowers of Citus, being able to run things in parallel. But when you have a foreign key from a distributed table to a reference table, then running things in parallel, especially in a transaction block, causing some issues. So let me dive a little bit more onto this. So so maybe you remember from the earlier slides is that so if whenever there's a foreign key check happening under the hood, Postgres and also Citus is running a SQL command, and that SQL command was also acquiring some logs. So imagine that if in a transaction block, the parallel executions that are triggered for a single distributed query is trying to acquire the same log. So that would cause deadlock issues. So to prevent that, what Citus requires is that if you are in a transaction block, and if you are modifying a distributed table which has a foreign key to a reference table, then Citus requires you to be in the sequential mode. So it can be very easily set with a setting, like with a command line setting on the pSQL, and then you can just run your transaction. And the other case is that if you first want to access a reference table which there is a foreign key from a distributed table, then Citus can automatically actually switches to the sequential mode, so that within the same transaction, the modifications to the distributed tables can go through the same connections, so that we don't get into concurrent sessions on the workers trying to acquire the same lock and to prevent deadlocks. And actually, the second bullet also like requires sequential mode upfront is the one actually I explained first. So like if you are accessing a distributed table that has a foreign key to a reference table, then that operation cannot be parallel, because that would mean that the next command on a reference table should throw an error. So that's why you can adjust it upfront. Okay. Another interesting case is that foreign keys between distributed and local tables. So this case is completely not supported at the moment, because there's really no way of supporting collocation of the relevant data. The local tables are on the coordinator, the distributed tables are on the workers. So there's really no way to create local foreign keys. So that's why Citus currently does not support foreign keys between local and distributed tables. Okay. And this is also another interesting case. So Citus also currently does not support foreign keys from a reference table to a distributed table. So this could possibly be implemented with some additional limitations, because actually the relevant data is actually collocated on the worker nodes. But then it's not really much useful for data modeling. So it really didn't get any attention from our users. So that's why we never prioritized enabling this kind of foreign keys. But so that's why it's currently not supported. But if you are, for example, interested in this type of things, I think you can go to Citus's GitHub page and maybe file an issue on that, so that maybe we consider prioritizing this type of things. Okay, so this is my last slide, which actually aims to summarize what I have described so far. So, okay, Citus has 3 different table types, and then there's really one way of using foreign keys in Citus. So which is requiring the relevant data to be collocated in a single node. So for example, from local to local is just a green tick, which is supported with everything. And then throughout the presentation, I also discussed some of the limited cascade options. So like if you see a yellow tick, then those are the cases where you should think about the cascade options a little bit more. And then I also put a sequential execution requirement in the distributed from distributed to reference as a reminder of transactional different transactional behaviors for this specific case. So like this is really my mental model of thinking foreign keys in Citus as well. So just try to focus on picking foreign keys that are easily applicable by collocating the data, and also think about the cascade options so that we don't get into cascade related limitations. And also, like if you have complex transactional blocks which also involves distributed and reference tables, then think about creating foreign keys so that you don't need to use sequential execution. Thank you for listening my talk, and you can follow me at Twitter, and I'm also sometimes writing blogs about these technical topics on citusdata.com, so you can also follow me through there as well. Thank you.